Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So, topic here that we will discuss today over there it is the general characteristics of the transition elements. That what are their general characteristics? What are their main properties? So, basically, transition elements. When we have a simple look on it, these are the elements that are called as D and F block elements. As in our previous lesson, we have learned about their some properties. Now here we will discuss their general characteristics. The general characteristics means the simple characteristics that are related to the behavior of the transition elements. Now what will be their behavior? What will be their general characteristics? So general characteristics that we will discuss over there, it is their binding energies and the second we will discuss about their melting points and boiling points. We will discuss over there its paramagnetic behavior, the behavior that can they be attracted towards the magnet or not. We will discuss about their covalent radii as well as we will discuss about their ionic radii, the radius of the ions that is known as the ionic radii, as well as we will discuss about its oxidation states. So these are the simple some general characteristics of the transition elements that we have. So the first one is the binding energies. Now, what does mean by the basic word which is the binding energies? Basically, when we look on all the transition metals, they show the good mechanical properties. As they are tough, they are strong. So they have good mechanical properties that they can be used for different purposes, as well as they are highly tough, they are malleable, they are highly ductile. And now, due to their toughness of all the metals, that indicates that they have strong metallic bonding, which is very important. They have metallic bonding, and that bonding is too much strong. If they have too much strong metallic bonding, this is just because apart from all the or electrons that are present in the S subshell, which is their outermost shell. The electrons that are underlying in the d orbitals or the d and f orbitals, they also participate in the bonding. Now, when we move in the series of the different transition elements, before this, you guys must know what does mean by the binding energies. If we have their nucleus, which is a smaller mass in the center, and we provide the binding energy to it, it will be helpful to separate the nucleons into the smaller mass. So this is the binding energy that is required to separate out all the particles of the different elements into it. This energy is known as the binding energy. But when we have a look on the different transition elements, as all the transition elements have these types of the properties that the metals must have, for this reason they have very high binding energies. Now, what is the main graphical representation for these binding energies? Basically, when we move from left to right, that is in the period, these are basically in any transition series of the transition elements. We just looked at the number of unpaired electrons is it is increases. What does increase? The number of unpaired electrons. They are going to be increased when we move from left to right in the period, and they are just increases up to the group number, which is group 5b to group 6b. And after that, there is a start of pairing of electrons, and the number of unpaired electrons goes decreases. until there it becomes 0 to the group number 2b. So that's why the group 2b elements are called as the non-typical transition elements. Like here we have the non-typical transition elements, zinc. We have here the other non-typical element, which is the mercury, and we have also the cadmium. It is also the non-typical element. All the other are called as the typical elements. So as the binding is just stronger up to the group number 6b, and just then it's just started to weakens upon the group 2b. So there is a trend of variation in the energies, which is called as binding energies. As in this graphical representation we can easily see that we have potassium, its binding energy is less than the calcium. We have scandium, we have titanium, vanadium, iron, then manganese. Then there is a start of the new group which is from manganese, then to we have cobalt, nickel, we have copper, and then zinc. It just element from the group 2b. After this, there is a star from cesium, barium, lithium, HF, Tu, tungsten, Re, ozone, Ir, platinum, gold, and mercury. So there is a variation, then first increase and then there is a decrease in the binding energies. These energies are called as the binding energies of the transition elements that we have. So in the first transition series, there is just a general increase, but after the vanadium, there is a decrease in the binding energy. This is just due to the change in the metallic structure, in which we just have a look that manganese, it is in present in the third transition series, and when it is present in the third transition series, then there is an increase in the binding energies that just ends up at the tungsten. Here and after this then there is again decrease in the binding energies of the transition elements that just variate in one way or another way. So there is decrease when all the 5d electrons started to paired up. So there is a general trend of binding energy of all the transition elements in the periodic table that we have. So this was all of the topic that we have today. I hope you guys understand, and if you have any queries, you may ask me about that in the comment section and I will get back to you guys soon. The next topic that we will discuss, it is a melting point of transition elements, as well as we will also discuss its boiling point in detail. For that time, you guys keep learning and have a good day.